Hello. In this video, I continue the Introduction to Coding Web Games using HTML, CSS, and JavaScript series with part 4. In the previous video, we learned how to draw a circle on our canvas element and even gave it a neat color gradient. In this video, we're going to learn how to animate that circle and make it bounce off the walls of our canvas. In order to do that efficiently, we will also be learning about objects. All the code contained in this video will be available for download at the link provided below. So let's get coding. If you recall, this is how we left our program. We still have the canvas and we have a circle drawn with a gradient and 3 colors. We have the white, gray, and black gradient on it. We're not going to change this much, but we are going to make it more dynamic. In the last video, I told you how I would address how to draw a rectangle in the center of the canvas, and also how to make your draw circle and draw rectangle functions more dynamic. Because as you can see, every circle is being drawn in the center, and every rectangle is being drawn at 10:10. So let's make that a little more interactive. In order to do that, we have to specify some parameters in our function name. Right after the name, within the parentheses, you need to specify that we want to take an x, a y, and these are all separated with commas, an x, a y, a width, a height. And since we're going to be doing a gradient, I want to go ahead and accept 2 different colors, a beginning color and an ending color. So we're going to give a color 1 and a color 2, and that will be, color 1 will be our starting color, and color 2 will be our ending color. Don't forget to separate them with a comma. So down here in our context.rect function, now instead of hard coding it with a 10, we can put that x in there and then use that y for the y coordinate. And instead of hard coding 100 for the width, now we put width there and height where the 50 goes. So now we take whatever is being sent to us through the function. When they call the function, they'll send us certain values, and now we will put them there instead of the hard-coded numbers. And remember, this x was the same as the other x on our gradient, so we can use the x and the y here because they were the same. But this one, if you'll recall, it was the x coordinate added to the width. So instead of 110, we're going to have to literally write x plus width. And again, this one was just the y coordinate repeated, so you can just write the y coordinate again. So now, every time we draw a rectangle, or every time we call the draw rectangle function, we have to send it these parameters. We have to send it an x, a y, a width, a height, a color 1, and a color 2. Speaking of, since I'm only using 2 colors, I'm going to get rid of all of the color stops in between the first and the last color stop, and I'm replacing the hard-coded string in here with my parameters. So this is going to be color 1, and this one is going to be color 2, and it will put whatever color I send to it in that value. So up in draw rect, I am now going to attempt to send it an x, a y, a width, a height, a color 1, and a color 2, and then we'll test our draw rect function and see if it's working. I'm going to keep it at 10, 10, 100 width, and 50 height, just for old time's sake for now. But now I need to send it 2 colors. Let's do blue and maroon. That's a nice color that we haven't used yet. It's a nice dark red. So now if I've done it correctly, I'm calling the draw rect, I'm sending it all of the proper parameters, and it should draw a rectangle in the corner exactly where we had it with the colors that I've sent it. It will also erase the circle because I commented that out. And there you have it. A blue to maroon rectangle at 1010, that's 100 by 50. Let's change this up. I'm tired of the 1010. Let's bring it out to 100 each. So that's 100x and 100y coordinate. Boom. So that is a dynamic function. That's how you can draw circles and rectangles all over with one function. You send it different parameters. So let's do the same for our draw circle. It's going to need much of the same, except it doesn't need a width and a height. Remember, all it needs is a radius because it's a circle. It still needs the color 1 and the color 2 because I'm going to do the same for it. I'm going to have the gradient on it, but just the 2 colors for now. So let me go in and comment out that third color I had in there. And instead of hard coding it, again, this is going to be color 1. And this one will be color 2. Whoops, too much speed. This is no longer going to be hard-coded either. Now I can put the x coordinate that I receive in here and the y coordinate that I receive in there. The radius that I need is going to be in there. These stay the same, however. I still want to start at the 0 angle and I still want to go all the way around. Okay, so I'm adjusting here now, and I'll make a mistake, but what I'm saying here is, if you'll recall, I go back half of the radius. So instead of saying 50, I can actually say half the radius. So radius divided by 2. And that will bring me back the same amount as if I just said minus 50. Because if I put the radius at 100, then half of that is 50. And in the case of the radius for the inner circle, that is again radius by half, but then divided again by 10 to get to 5. Pardon me. And I should go in and change the x and the y coordinates to say x and y, but I have momentarily lost my mind, so I don't do that. So you're going to see me test. Oh, yes, here where it said 100, I can just put the radius there, because that was the radius that didn't have anything done to it, so just radius. Now, I'm going to attempt to draw a circle, and I'm going to pass to it some coordinates, an x-coordinate, a y-coordinate, a radius, a color 1, and a color 2. I know I keep repeating myself, but it's important that you know that that's what I'm doing. And I still want it in the center, so the x-coordinate I send it is canvas width divided by 2, and the y-coordinate that I send it is canvas.height divided by 2, because again, for a circle, that will get me right in the center. I'm going to change up the radius, or no, actually, I didn't change up the radius. I will later. I'm going to make this a white. Color 1 for is going to be white, and color 2, I believe I chose black. And these have to be a string within quotation marks like that, separated by commas. So now that I am sending all of this information to the draw circle, I'm going to test it. But again, for the gradient, I never changed the x and the y coordinate to reflect the dynamic status. It's still hard coding it to the center of the circle, or the center of the canvas. So when I move, oh, I didn't move it. Yes, okay, this is correct. I'm sorry, I drew right now. So if I draw it in the center, it's fine, because the gradient is in the center. But if I move the circle like I'm doing now, I'm moving it over, up and over to the left by 100 pixels, or to the right by 100 pixels, down and to the right by 100 pixels. But my gradient is still hard-coded to the center of the canvas, so it didn't move with the circle. So I suddenly realized, oh yeah, I have to come in here, and everywhere it says canvas.height divided by 2, I need to put the y, and everywhere it says canvas.width divided by 2, I need to put x. Just like I'm doing now. And that makes it dynamic. So now it'll take the x coordinate that I sent to it and the y coordinate that I sent to it, and it will readjust where that gradient is so that it follows the circle instead of staying in place like it did. You will see me test it now, and my gradient will reappear like magic. Okay. Now that we've got that taken care of, I will very briefly show you how to draw a rectangle in the center of your canvas. As it stands, we have it hard-coded to 100, 100. But to draw it in the center, you would think it's exactly like a rectangle, a circle, but this is what happens if you do it like you would a circle. If you give it an x-coordinate of canvas.width divided by 2 and a y-coordinate of canvas.height divided by 2, it will take the upper left-hand corner of your rectangle and put it there. So that upper left-hand corner is exactly in the center of your canvas, which is great, but your rectangle is not. So you have to actually bring the x-coordinate back by half the width of your rectangle, and in this case it's 100 pixels wide, so we're just going to come back 50. And in the height case, you have to go up, so that is minus the height, and we have a 50 pixel height, so we go up half that, and that's 25. So now we've sent the corner to the middle and then pulled it back by half in each direction, and that puts the center of our rectangle directly in the center of our canvas. So what we've actually done is taken it and pulled it to the left and up, as I indicated there. Okay, so that's that. I promised I would show you all that. Now we can move on to the fun part. Now we're going to animate our circle. And there's a few things that we need to do before we animate a circle. First thing is we have to create an array to keep track of all the things that we want to animate. An array is a type of data structure that lets us keep track of a lot of things at once. So let's type let sprite array, and I've misspelled it here, but I'll come back and I'll fix it. So let sprite array equal the square brackets. That's open and close square brackets. That means an array where we can put objects. And here I'm fixing it now. So now that we have an array in which to put our objects, we have to actually define an object to put in there. And that's not going to be hard. I like to put it at the top above all my functions. So down here, above your function, one moment. Okay. Above the function, type let, and I started off with just sprite object because that's usually how I do it, but then you'll see later I'm going to change my mind to circle object, but for now just write sprite object. And when you create an object, it is curly braces colon. So sprite object equals open close curly braces semicolon, excuse me. And then within those curly braces, you have to define some attributes like I'm doing now. Exactly like I'm doing now. You just we're going to give it an x attribute, so that's an x colon. Then you put the attribute there. We're giving it a 0x coordinate, and then a comma. Not a semicolon as I had it. A comma. It has to be a comma. Then on the next line, we're giving an attribute of y. So it's y colon 0, which is the attribute, comma. On the next line, we're going to need a radius for all circle objects. So we give it a radius attribute. So it's radius colon, and again, we'll just set it automatically to 0, comma. I went ahead and gave it a width and a height. Like I said, at first this sprite object was going to be kind of a catch-all and you were going to be able to draw rectangles and circles with it, but I changed my mind. But I still left the width and the height in there, even though we're not going to use them. You can write them in there if you want. You don't have to write them in there. It's fine. I wrote them in there. I left them in there. Width, height, the same way as everything else. You do need, however, an update. So make sure you include update colon, and we're going to make this a function. And you do that just like you do regularly. You write function, and then open and close parentheses, open and close curly braces, except this time you're going to have that comma because we're going to put something after this. And then within those curly braces, you define what you want your update function to do. And in this case, every time we update a sprite, we want to add 1 to its y coordinate. So we're going to say this, and when we say this, we mean this object that is calling the function. Whatever object is calling the function, it's going to do it to this. So this dot y plus equal 1. So every time this sprite or whatever sprite updates itself, it's going to add 1 to its y. Because if you remember, plus equal means you take what's already there, which in this case is 0, and you add 1 to it. But next time it updates, it'll be 1, and then it'll add 1 to that, and it'll be 2. And then the next time it updates, it'll add 1, and it'll be 3. Another way to write plus equals, if you're just doing it by 1, you don't have to write plus equals 1. You can just say this dot y plus plus. It's the same as, those two are the same right there. So I'll just leave it like this because this is easier to read. This dot y plus plus, that means add 1. Now, every sprite needs a draw function so we can draw it, so we can actually see it. And just like update, it's going to be a function. So you do draw colon space function, open and close parentheses, open and close curly braces. Now in this case, you don't need the comma because there's nothing after this draw function. There's nothing coming after it, so you don't have to separate it by a comma. This is where I've changed my mind, and I've decided instead of calling it a sprite object, I'm going to call it a circle object, because here in the draw function, I want to specifically call the draw circle function that we defined earlier. And I'm going to pass it the 5 parameters, the x, the y, the radius, the color 1, and the color 2. And if you're wondering where I'm going to get those, the circle object already has those by itself. It has its own x coordinate, its own y coordinate, its own radius, so that's what I'm going to send. I'm going to send this dot x, this dot y, this dot radius, because again, oops, this is a circle, so it needs a radius. And I suddenly realized here that when I'm defining my circle object, I forgot to give it 2 attributes. I forgot to give it the color 1 attribute and the color 2 attribute. So somewhere right here underneath height, I just added 2 attributes. Color 1 colon, and I made that white, even though you can change it, but it'll default to white, comma, color 2 colon, black and white, comma, don't forget your comma to separate it from the update function. Okay, so now that I have those 2 attributes in my circle object, I can use them. When I call draw circle, I can now say this dot color 1 and this dot color 2. So every time this draw function is called, it calls the draw circle function and sends its own info, and draw circle takes that and draws the circle however it is being told to draw it. We're not quite done yet. So we've defined a circle object, but now we need to make a function that will make a circle, and we're going to call that make circle. So function make circle, and it's going to accept the same parameters, again, open close parentheses, open close curly braces. We're going to accept the same parameters as draw circle, x, y, radius, color 1, color 2, because in this case we're just going to be passing it along. We're going to call make circle, and make circle is going to take that info, and first thing it's going to do, and this is important, so when you call make circle and you send it an x, y, radius, and color 1, it says let temp circle, as in temporary circle. We're going to take temp circle and we're going to say let it equal object, capital O, object dot create, parentheses, semicolon, and in that parentheses you pass it the circle object that we have defined. So you're saying let the temp circle variable be equal to an object that is our circle object. You have created a circle object, and you put it in temp circle, and now temp circle has an X, temp circle has a Y, temp circle has a radius and a width and a height and a color 1 of white and a color 2 of black. It has an update function and it has a draw function. All of that has just been placed into the variable of temp circle. So now we want to change some of those attributes to whatever we want, really. And I started off here, I kind of forgot where I was in the coding, and I started to hard code it. And you'll see that I catch myself. I do not want to put tempcircle.x equal to 150. What you want to do is you want to write tempcircle.x is equal to the x that you've passed in make circle up there. You see how it says make circle, x, y, radius, color 1, color 2. That's what you want to be using, and I will realize that here shortly, like about right now, I think. No, I didn't. Hold on. I'm still hard coding, oblivious. I think it's about here that I realize, oh, wait a minute. Yes, this needs to say x. This needs to say y. So what I'm doing is I'm taking the x, the y, the radius, the color 1 and color 2 that I passed in the make circle function, and I'm assigning it to the attributes of the object that I have just created. And it's pretty straightforward. X equals x, tempcircle.y equals y, tempcircle.radius equals radius, color 1 equals color 1, tempcircle.color 2 equals color 2. But after you have done all this, after you have created the object and assigned all of this to it, you need to then take your temporary circle, your temp circle, and push it into your array. So you say sprite array dot push, parentheses, open close parentheses, semicolon, and into that array you're going to push your temp circle. And what that means is it puts it into the array on top of everything else that's on the array. So since we don't have anything else in the array, now the sprite array only has one object, and it is the temp circle. We still haven't made our circle though. We have defined how to make it and what to do, what kind of object to make it, but we have to actually make the circle. So you do that by calling make circle. And this is where you pass in your parameters. So I want the x, I want it to be at x coordinate 150, y coordinate 150, and this time instead of 100 radius, I'm going to give it a 75 radius. Color 1 is going to be a pink as the highlight color, and then red as the outer color. And if I have done this correctly, when I go to the canvas and I refresh, it should make a circle using those parameters that I sent, 150, 150, 75, pink and red. It takes those parameters and it creates a temp circle object. It puts all of those parameters into temp circle and then takes temp circle and puts it into my array. So what now? Well, I need to write a few more functions in order to animate this, in order to actually get this drawn and animated. Yes, pink and red. It still has, by the way, the same update function and a height and a weight of 0, or width of 0, because we didn't change those. All we changed was its x, its y, its radius, its color 1, and color 2. So now, in order to actually animate this, we're going to need a few functions. The first one's going to be update. So at the very, very bottom, write function update. Close, open parentheses, close parentheses, open curly braces, close curly braces. And then within those curly braces, it's a very simple process. We're going to do something called a for loop. So you write for, and then open and close parentheses. And within the parentheses, we want to say for every object, you know what? Let's do sprite. For every sprite of sprite array. And what this is going to do is it's going to run through every array or every sprite that is in sprite array, or every object in sprite array, and do something with it. And what we're going to do is we're going to say call the update function. So for every sprite of sprite array, we're saying sprite.update, as in call your update function that we defined above. every sprite that we call that is a circle object has an update function of this.y++. So that is what's going to be called every time we call that sprite's update function in the main update function. After you've run through and updated every sprite, you want to actually render that sprite, as in draw it. You want to actually draw it out. So you need another function called render. Function render, open parentheses, close parentheses, open brackets, curly braces, close curly braces. And within render, this is where you do the actual drawing. To draw on a canvas, you first have to clear the canvas. Every animation frame needs to be cleared, or else you're just going to be drawing picture on top of picture on top of picture. So to do that, write context, or excuse me, type context.clear rect, capital R, open parentheses, close parentheses, semicolon. And within clear rect, it's the same as fill rect or the rect function. You need to give it an x coordinate, a y coordinate, a width, and a height. But we want the entire canvas cleared. So we're going to start up at the corner of 0, 0. That is going to be where we start. And we want it to clear the width of the canvas. And we also want it to clear the height of the canvas. So basically what context.clearRect 0, 0 canvas.width canvas.height, what this does is it just erases our entire canvas. Every time we update and render, it clears the canvas so that we can then go back in and say for, again, sprite of sprite array. This means for every sprite in sprite array. So for sprite of sprite array, do something. And what we want to do is call the sprite.draw function this time. So now after clearing the canvas, it's going to go through every sprite in sprite array and call its draw function, or have it call its own draw function more precisely. We're not quite done yet. This would work once, but we need this to happen over and over and over to animate it. So we write up in the update function, right underneath render, type request animation frame with a capital A, capital F, and pass it the update function, just as you see there, update with no parentheses behind it, comma, canvas. And we're saying request an animation frame on this canvas and then call update. So every time request animation frame is called, it calls update. And this will happen about once or 1,000 times per second. So about 1,000 times per second, update and render are going to be called, and every sprite in sprite array is going to be updated, and then the canvas is going to be cleared, and then every sprite in sprite array is going to have its draw function called, and that is what results in the animation. The constant clearing, updating, and redrawing of the pictures will animate it. And if you add 1 to the y coordinates every time you animate something, that is just going to make it look like it falls. So if I've done this correctly, if everything is working, when I refresh the browser next, the ball that I'm animating should start wherever I put it and then slowly fall down. But as you will see, I didn't get everything exactly correct the first time. I inspect again and I find that there's no errors in my code, so that means I've done something wrong with the logic. And then I realized that we never called the update function. You have to actually call the update function for it to work. And then I remember, so that's at the bottom. My favorite way to call the update function is to put it in a window.onLoad event listener. You don't need to know what that is. Just type what I'm typing here. Type window.onLoad equals function, open close parentheses, open close curly braces. Within the curly braces, you call your update function. Now, what that means is when the window is done loading, when it's loaded, it'll call that update function, and there you have it. A pink and red balloon with or ball with a 75 radius that is slowly falling with every frame. So we've successfully animated it. And I was going to show you how to get it to bounce off of the walls, but this video is getting a bit long. So what I'm actually going to do is I'm just going to show you some very basic logic. Up here in the update function, we're going to tell it to do something. And what we're going to tell it is to check to see if this dot y, which means the very center, because this is a circle and the y coordinate is at the very center, if this dot y plus this dot radius, so that means the center plus the radius, that means the very, very bottom of the circle. So if instead of saying this dot y plus this dot radius, I can just say the bottom of the circle. So if the bottom of the circle is greater than or equal to the height of the canvas, I want it to do something. Now, that's actually incorrect. I want the opposite of that. So what I'm going to do is I'm going to encase this entire expression, this dot y plus this dot radius is greater than or equal to canvas dot height, and put all of that in parentheses. And then outside those parentheses, just outside those parentheses, put an exclamation point, and that will reverse everything. It'll make it opposite. So now instead of checking to make sure that this dot y plus this dot radius is greater than or equal to canvas dot height, I'm checking to make sure the opposite. So if this dot y plus this dot height is not greater than or equal to the canvas dot height, I will increment the y by 1. What this says, basically in layman's terms, is if the bottom of the balloon is still above the bottom of the canvas, then let it go down. But as soon as it's no longer above the bottom of the canvas, it stops, just like that. It is no longer adding to the y coordinate. So now we've added a little bit of logic to our animated ball. And congratulations on finishing part 4 of the series. I hope you're feeling more confident in your coding abilities, and as always, I implore you to play around with this code and to make it your own. In the next video, we will learn to draw images onto our canvas and also how to use sprite sheets. I hope to see you there.